Hello and welcome to the Introduction to Calculus video part 2. Before we start this video, I just want to take you back to Year 8 and remind you of how we find the equation of a line when we're just given the table of values. So the first thing we do, if we're given a set of values, yes, we could plot them all up on the number plane and have a look at the gradient and where it's cutting the y-axis. However, we can do it without needing to plot the points. The first thing we do is we look and we try and find a pattern, and the pattern is quite nice. This is going up by 2 each time. So this tells us that the equation of this line, well, the general equation of a line is y equals mx plus c, but this going up by 2 at a time tells us that it's going to be y equals 2x. Now, to work out what the plus c is, you will remember that the plus c actually tells us our y-intercept. So to get our y-intercept, we have a look at what happens when x equals 0. And in this case, when x equals 0, y is equal to 3. So this is the line y equals 2x plus 3. We didn't have to plot the points. We didn't have to look at what it looked like. We can just find the equation of the line from that table of values. So just keep that in mind when we're doing our lesson today. So I'm going to take you back to the screen I had earlier. So this is the first part of the video up here, and this is the second part. Now we're talking about trying to find the equations or the gradients of tangents at a particular point on a curve. And we know we can't do it using our m equals y2 minus y1 on x2 minus x1 because we actually only have one point. We've got a curve of some sort. We're trying to find the equation or the gradient of the tangent right at that point, so we've only got one point. Our calculators, however, are pretty smart and they know how to do this. So what I'm going to do now is show you how, on your graphics calculator, you can work out the equation of the tangent at any point on a particular curve, and we're going to do a bit of an investigating into what might be happening here. Now, why have I got those pictures on the screen? Well, they are investigators from some really bad shows in the 80s. You might recognise Bruce Willis and Pierce Brosnan there. That can be your homework to go and find out what those shows are. They were pretty terrible. All right, you've got your graphics calculator handy. The first one we're going to have a look at is y equals x squared plus 3x. You will recognise that as being the graph that we looked at in our lesson number 1. So we're looking at y equals x squared plus 3x. We know that it looks like this. And what we're going to do is we're going to have a look at what's happening at all these different points on that curve. So we're going to have a look at the point where x equals minus 4. We're going to get our calculator to tell us what the tangent looks like at that point. We're going to look at x equals minus 3, and we're going to get our calculator to tell us what the tangent looks like at that point, and so on. So let's get our graphics calculators up on the screen and have a look. Now I've prepared mine already. So I have put in y equals x squared plus 3. Actually, it should have been plus 3x. So I'll fix that up now. X squared plus 3x. And I'm going to graph that and see what it looks like. Now I just need to fix my... There we go. So to get the calculator to tell you what the tangent looks like, we need some new functions on our graphics calculator. We're going to draw on a tangent. So I'm hoping that on your graphics calculator, pretty much bang in the middle of the top section, we've got the word draw written above the program button. So I'm going to press second, draw. I'd like to draw a tangent. So I'm going to press number 5 for tangent. And I would like to find a tangent where x is equal to minus 4. So I will type in here minus 4. So I'm asking the calculator to draw a tangent at the point where x equals minus 4. And there it is. It tells me that the tangent at that point there is y equals minus 5x minus 16. So if I go back to my document, if it will let me, what happens at this point here is that it tells me that the equation of the gradient is y equals minus 5x minus 16, which means that the gradient of the tangent at that point is minus 5. So I'm going to write minus 5 in here. Now, I haven't filled out any of these y values yet, so maybe I should go and do that. I'll get my graphics calculator again. I'm going to delete that line because I'm going to do lots of tangents on this picture and it's going to get very messy. So if I want to get rid of it, I can just put a second draw again, and the first instruction there for number 1 is clear draw. So I'll just press 1 and then I've got my graph back. So before I go any further, I probably should find my y values. Above the top right hand button here where it says graph, above that you will see table. So I can press second table and I can look at all my x values and my y values. So this tells me what my y value is going to be everywhere on that parabola. So I can go back to my document and write those in. I've got minus, I'm going to do this in a different colour. I'm going to do this. So when x is equal to 4, minus 4, y is equal to 4, 0, minus 2, 0, 4, 10, 18 and 28. So they're just the points on the curve, but what I'm looking for now is the gradients of the tangent at each of those points. So on my graphics calculator, I now am interested, there's my graph, I'm now interested in what's happening when x is equal to minus 3. So again, I'm going to do second, draw. I would like to know the tangent, so I'll press number 5. I want to know the tangent when x is equal to minus 3. So I press enter. There's my tangent when x equals minus 3, and it is the line y equals minus 3x minus 9. So minus 3x minus 9, y equals minus 3x minus 9. That line has a gradient of minus 3, so I'm going to put minus 3 in here. I will do one more with you and then I'm going to leave you on your own. So the next point I'm interested in is what's happening, what is the gradient of the tangent when x equals minus 2. So I'll go back here, I'll get rid of that line that I drew, so second draw, clear line, and now I'm going to do second draw. This time I'm interested in the tangent when x is equal to minus 2. So here it is. It's minus x minus 4. So here I've got y equals minus x minus 4, and the gradient of that line is minus 1. I would like you to continue doing that just for this first parabola, and then we'll have a look at the other parabolas on this sheet. Now this sheet I'm hoping you can download or you have printed out, or perhaps you can write on your screen. So there is a sheet for this. You don't have to draw it all up yourself. Okay, so pause the video, finish the rest of this table of values, and then let's come back together and have a look at what's happening here. See you soon. Alright, so you finished a table of values and I'm hoping that you can see a really nice pattern here. Let's go and get rid of these things down here. They were useful for telling me the gradient, but I don't actually need to know those equations. I just wanted to find the gradient. So what I'm going to do now is I'm actually going to ignore these y values, and I'm just going to think of this as being a table of values. So I'm looking at the relationship between the x coordinate and the gradients. And I'm hoping that as you did this, you saw that there was a nice pattern. You saw there was a pattern here where these numbers were going up by 2. So this suggests to us that there's an equation we could use for this particular line. Now I cannot write here y equals because these are my y values up here. I haven't used those. Now just for now I'm going to use the notation y dash, and we'll talk more about notations later on. I'm going to say y dash, and that's going to denote how I find the gradient function. It's equal 2? Well, they're going up by 2, so it's going to be 2x. And what happens when the value of x is equal to 0? The y value is equal to 3. So that means if I wanted to continue this on my calculator, but I didn't want to have to do all the ones in between, I just wanted to find what would be the gradient when x was equal to 10, that I could just do 2 times 10, which is 20 plus 3, that the gradient would be 23. That wouldn't be telling me what the y value is, just telling me what the gradient of the tangent will be at that point in time. So this is pretty nice, and it's going to lead us to be able to find the gradient function for lots and lots and lots of curves. So just to tidy up this one, we started with y equals x squared plus 3x, and we found that if we wanted to find the gradient of the tangent anywhere on that parabola, and we denoted that with y dash, it was equal to 2x plus 3. So this is what we're going to keep in mind and see if we can find some kind of pattern. You might already be able to see it. Let's move on to question number 2 now. For question number 2, we've got a different parabola. We've got y equals 3x squared minus x. So let's go to our graphics calculator and let's do that one. So I'm just going to turn that first one off, and I'm going to put my equal sign on that. 3x squared minus x. I'm going to graph it up and see what it looks like. And I'm going to do the whole process again. So I'm going to say second, draw tangent at x equals minus 4. There it is there, minus 25x minus 48. So y equals minus 25x minus 48. That gave me a gradient of minus 25. Now again, I have to find these y values, so I will, on my graphics calculator, just have a quick look at that table of values. There they are there, and I can put those values into my table. So I can go back here and write in 52, 30, 14, and so on. Okay, so I'm going to get you to do that for number 2 and number 3 and for number 4. Now you might notice that number 4 is a bit different because these first 3 were all parabolas, and number 4 is not a parabola, it's a cubic. Okay, so they're all polynomials. Remember, we did polynomials in first semester, but this last one is a cubic, so something different's going to happen there. But what I want you to do now is pause the video, and it's going to take you some time to go in and fill out the tables of values for all these other functions, and I will see you soon. Now you're back with me now, and you're probably just checking your answers against mine. And you're being patient with me while I write these in. Probably haven't finished the one above, so I'll do that in a minute. So I'm just going to write my answers in, and we'll have a look at the equations for these things together in just a moment. Final values here. All right, so for number 2, we were looking at y equals 3x squared minus x. So we're looking at y equals 3 minus 3x minus 1. We're looking at a concave up which cut at 1/3 and at 0. And we're having a look at the gradient at all these different spots. So it made sense that they went from negative to positive. I'm hoping you saw the pattern. So the pattern here was that these were going up by 6 each time. Okay, so we're saying that y dash, to find our gradient function, is equal to 6x, and the value of y when x was 0, the value of y dash I should say, was equal to -1. So we started off with y equals 3x squared minus x, and we had a gradient function of 6x minus 1. In number 3, this time we had a concave down parabola, so when you drew that, it was more like, oh gosh, I'll have to do that one. Actually, I'm going to cheat and go back to my graph here. In fact, when you graphed this, you probably found, or may have found, that you needed to change your window on your calculator to be able to calculate all these. So when we graph this one, this graph, it goes up over the screen, and when you went to find values when x is equal to -4, it may have said, oh, I can't do that. So don't forget that you can change the window on your calculator by pressing the window button, and we can probably narrow down our x-axis from -5 to 5. We can probably change our y minimum to -80, our y maximum to 20, and perhaps we'll go up by values of 10. So when I graph that now, I can see the whole parabola, and I will be able to get values for these tangents. So second, draw a tangent at x equals -4. Draw that in, and there it is there. Y equals 40x plus 100. And that's a good way around doing that. So that's what that graph looks like. And we're finding gradients of tangent as we go along. Now again, you would have seen a nice pattern here for our gradient function. And these ones are going down by 10. So y dash is going to be equal to -10x. When x is equal to 0, our y dash function is 0. So it's going to be, we won't write it in really, will we? We wouldn't bother putting plus the 0 there. Okay, so what we've started with, that y equals -5x squared plus 20, and that y dash, the gradient function, was equal to -10x. So again, you might be seeing a nice pattern here, and we'll have to see if it works with our next one. Our next one's a bit different because this is our cubic. So when we graph it up, it's not going to be a parabola, it's going to be a nice cubic. So I again will turn my equal sign off that one, put it on this one instead, press graph, and there's our nice cubic. I'm going to have a look at what happens when I draw in tangents at different points along this curve, and I might do one more just for fun. I might do second draw, I might do a tangent when x equals 1. Okay, so we can see those tangents are going to go, they're going to be positive, and then they're going to be negative, and then they're going to be positive again, and so there's a bit more, a different pattern when we've got our cubic. So you've filled in your table of values, and this time you will have noticed that we haven't got one of those nice linear patterns. Okay, it doesn't go up and down by the same number, so that's not going to help us here. But hopefully what you have noticed is this nice symmetry. Okay, so we've got these things matching here. And when we have a symmetry like that, that reminds us of a parabola. I'm hoping it does. So if I had drawn this up, I would get a nice parabola. So I'd have 0, -4, I'd have 1, -1, I'd have 3, 23, and -3, 23. So I'd have a parabola like this, and it's not immediately obvious what that parabola is. Good on you if you worked out what it was. I'm going to tell you that it's the parabola y dash. So we want some formula for this. What's happening here is equal to 3x squared minus 4. And there's ways to find that parabola. We're not that interested in it right now. But when you have a look at your assignment, you will see the answer to that. So in this one, we started off with y equals x cubed minus 4x, and we ended up with our gradient function being 3x squared minus 4. Now, I'm hoping that right now you started to see a pattern between what we started with and what the gradient function is. What we started with and what the gradient function is. All these things here. Keep in mind also that I can now find the gradient of the tangent anywhere on this. Now remember, that's a picture of our gradient function, so that the graph itself looks more like this. I can find the gradient of the tangent anywhere here. So if I want to know what's happening at x equals 10, I can say, well, it's going to be 3 times 10 squared, which is 300 minus 4. So the gradient would be 296. The gradient of the tangent when x equals 10 would be 296. That's probably off the screen of your calculator. So I'll leave this lesson there. That will have taken you some time, and then we're going to go into the magic of how this really works in our next lesson. Thanks for everybody. Bye.